Hi everyone, today is Friday, September 1st. So today we have the first homework assignment due, right everybody? Have you started? Yes, good. Remember, you can redo the problems again and again until you get perfect scores, right? And I hope the first attempt you try to do it on your own, and then the second attempt you can look at the sample homework solution and try to figure out what's the step to do the homework. Okay, everybody? Hello. All right, so next Monday, Labor Day, no class. And then so today we will continue on session 3.1. And next week will also be 3.1 as well. This is a long handout. Okay. So last time we talked about the definition of limits, right? And we also talked about the left side of limit and the right side of limit, right, everybody? And we also talk about like when limit does not exist, right? It could be it goes to infinity, or it could go to minus infinity, or the left side and the right side they do not match, then the limit does not exist. And maybe the function is like this, oscillating between two numbers, so the limit does not exist. Okay. All right. So today let's continue to learn limit laws. So the limit of many familiar functions as x approaches a value of a is simply the function evaluated at a. Do you remember our steps? So when we saw a limit problem, the first step we try to plug in a number and see what happens. If we get something weird like 0 over 0, we don't know what it is. Then that means there is a bad guy, right? The bad guy makes the numerator and the denominator 0. So if we have the numerator and denominator, they're both polynomials, then you can try to factor it. So factor it, hopefully you can see the bad guy, then you can cancel the bad guy, and plug in the number again. Right, everybody? Or last time we also saw an example of difference of square roots. Remember when you see difference of square root, to carry out the square root, you multiply by its conjugates. Because a plus b times a minus b is a squared minus b squared. The square will cancel the square roots. That's why you can simplify and see the bad guy and cancel it. Do you still remember, everybody? Mm-hmm. Yes. So last time we also like give you a graph, and then you figure out the limits, and you figure out the function value. Okay? If we cannot find a number to describe it, the limit we say does not exist. The function we say not defined. Okay, everybody? So in this case, f of 4 is not defined. Okay? F of 2. Do you see the open circle? The point is missing. F of 2 is not defined. All right, everybody? Okay. So limit laws. So for many of the functions, we can plug in a function. So many of the functions, we can do that. Okay? But if you get something weird, like 0 over 0, then we need to do more things. Okay? Next use, you should be able to compute exactly the limits of many familiar functions using the theorem from this section. Okay, limits of a linear function. So let a and b and m be real numbers. For any linear function, well, the limit is you plug in the a into the linear function. You get ma plus b. Okay, everybody? So just plug in the number to see what happens. And because linear function, you don't have something weird in the denominator. There's no denominator, so it's okay. You will get a number. So that's the limit. Okay, next, limit laws. So assume limit x goes to a f of x and limit x goes to a g of x exist. The following properties hold, where c is a real number and m is positive and n is positive are integers. Okay, let me make sure that I hit record. Okay, I did. Good. Alright, we have sum. Limit of sum equals sum of limits. Kind of makes sense, right? Limit of sum is sum of limits. And limit of difference is difference of limits. Constant multiple. If you have a constant, you can move the constant out. With constant has the limit of f. And we also have product. Limit of product is product of limits. You kind of distribute the limits to all the factors, right? And quotient. Limit of quotient is quotient of limits. But you have to be careful because the denominator cannot be 0. Okay? So, for example, if you have something like limit x squared over x, well, when x goes to 0, you cannot move the limit to the top and move the limit to the bottom. That's not okay because you get 0 over 0. That's not good. Okay? So if the denominator limit is 0, you cannot move it. Actually, for this problem, you can just simplify it, right? You simplify this x squared and x, you get x left. So you get x left, then you can plug in the 0. You get 0. Okay? Yeah. So, and then limit f to the n, we can move the limits inside. And limits for fractional power. You gotta be careful because if your m is 2, for example, then you get square root, right? For square roots, you want it to be defined. The things inside the square root must be greater or equal to 0. That's why, in this case, we require f of x to be greater or equal to 0 for all x near a, so that this is defined. Okay, everybody? And polynomials and rational functions. Polynomials, same thing. You just put the a and x, right? And rational functions, you plug in the x is a, but be careful, you want your denominator not equal to 0. Okay? So remember, it's like what we were doing. If you plug in it, you get 0 over 0. You need to do factoring, cancel the bad guy. Then you can plug in again. Okay, everybody? So remember, these limit laws also hold for one-sided limits. So you can replace x goes to a by x goes to a from the plus means left or right. Plus, right, positive side. And then minus is from the left. Yes. Okay, look at the following. So that's why here, number 1, limit x goes to minus 1. So we plug in minus 1 and see what happens. So we get 3 times, and here, minus 1 squared minus 4 times minus 1 plus 1 all over 2 minus 5 times minus 1. Okay, so this limit law is saying that if you see rational function, plug in and see what happens. Okay? What's minus 1 squared? 1. So this is just 3, right? 3 times 1 is 3. And then, oh, do you see the next number? Minus 4 times minus 1 becomes positive 4. Oh, attendance. Okay. Thank you. And then plus 1. How about denominator? 2 minus 5 times minus 1 become plus 5, right? Okay, what's in the numerator? 8. Denominator, 7. See, this is a good number, right? So this is the limit. Okay, if you plug in and you get 0/0, that means you need to do more things. Okay, but if you plug in and get a good number, that's the answer. Okay? All right, let's keep going. Everybody finish example 1? Okay, example 2. So example 1, we know the formula of the function. Example 2, we don't know the formula of the function. So what we need to do is use the limit law. So let's look at this. We use the limit laws because this is a quotient, right? We can move the limit in the numerator and move the limit to the denominator, right? Limit of quotient is quotient of limits. So let's do that. Okay, so that equals, please carry your limits all the step when you still have the x. All right, so this is the fourth root of f of x, g of x squared plus 5, h of x minus 1. And then denominator, we have g of x, h of x plus 3 cosine x minus 2. Is that okay, everybody? So we use the limit laws. Limit of quotient is quotient of limits. You kind of like move the limit inside and kind of like distribute it. See, this is a 4 root, so we can move the limit inside the 4 roots. Yes, everybody? All right, so we got the 4th root. And we get limit x goes to 2, f of x. And we can also, okay, if we want to do it step by step, let me do it step by step. Okay, and then if you get used to it, you can maybe skip some step. Okay, we move the limit inside the power, and then downstairs we move the limit. So limit of sum is sum of limits. And do you see the limit of product is also product of limits? Yes. And the 3, we can move the 3 outside of the limit. We're using the limit laws. Limit of sum is sum of limits. And limit of products is product of limits. And for the constant coefficients, we can move it outside of the limits. Is that okay, everybody? You kind of move the limit inside. And let's do the same thing in the numerator. So we have the 4 root, and we have limit f of x, and times limit g of x. I can put the square outside. Yeah, here I'm doing 2 things in one step. I have limits of sum is sum of limits, and the limits of product is product of limits. And you can have for the power, you can move the limit inside the power. Is that okay, everybody? What we're doing is move the limits inside. And also plus 5, limit x goes to 2, h of x, and then minus 1. Okay, denominator. Let's just copy it. Okay, let's see. Now we're ready to plug in. So make sure you move all the limits inside. We're ready to plug in. What's the limit of f? Look at the problem. What's the limit of f when x goes to 2? Limit of f is 7, right, everybody? It's 7 here. 7. We now can plug in. So we get 4 roots 7. Next, what's the limit of g? 4. Oh, do you see the square there? So it's 4 squared plus 5 times, what's the limit of h? -6 minus 1. All over limit of g. 4, right? Limits of h? -6 plus 3 times limits of cosine. Okay, let's plug in. Plug in x is 2. What's 2 minus 2? 0. What's cosine 0? 1. Right, everybody? So we plug it in. So when we plug in, we get cosine 0, and that's 1. And you get 3 times 1 is 3. Good. Let's keep going. 4 roots. Okay, what is 4 squared?
What did you plug into the cosine again?
Oh, 0 to 2.
Oh, the 2, okay.
Yeah. So x goes to 2. So you plug in x is 2. So 2 minus 2 is 0. Yeah. So not only for polynomial or rational functions, if you have exponential function, logarithm function, all the trig functions, what you do is you plug in the number first and see what happens. If you get something weird like 0 over 0, and then you do something else. Okay, everybody? All right. So let's keep going. 4 squared is 16. 16 times 7. 16 times 7. Yeah, so 6 times 7, 42. 7 times 1, 7. 7 plus 4 is 112. Right, everybody? 112. Oh, this is minus 30. Okay, minus 30, which is what? 82. And then minus 1. 81. Oh, 4 root of 81. Yeah, very good. It's 3. Where is my... All right, here. This is too long. 81, and we know that's 3. Okay, look at the denominator. Here? Oh, we plug in x is 2 in the function. See, limits? How do we calculate limits? We first plug in the number and see what happens, right? So, cosine of 0, yes. Cosine of 0 is 1. It's a good number. If you get 0 over 0, then you have to do something else. But if you get something like any good number, then that's the answer. Okay. Denominator, 4 times -6 is -24 plus 3. -21. Oh, what happened? 3 and 21, what do you cancel? 1 over 7. Exactly. So this is the answer. The answer is minus 1 over 7. Is that okay, everybody? So when you see these kind of problems, you move the limit inside. Okay? So use all the limit laws. Limit of sum is sum of limit. Limit of subtraction is subtraction of limit. Limit of product is product of limit. Limit of function is function of limit. And when you see the powers, we can also move the limit inside the power. Okay, everybody? So you move the limit inside until you get limit of f, limit of g, limit of h. Then you can plug in. And besides f, g, h, if you have some other functions like cosine, exponential function, log, or other trig functions or other polynomials, you just plug in the x's too in this case. Okay. Good. All right, that's example 2. Okay, now let's do more example. Example 3. Let's see, if we plug in 2, what happened? 2 squared, right? Minus 7 times 2 plus 10 over 8 minus 2 cubed. 2 squared is what? 4. 7 times 2 is 14. Ooh. What's 2 cubed? 8. Oh, do you see we get 0 over 0? That's not good. It means we have a bad guy, right, everybody? So, and do you realize the numerator and denominator, they are polynomials? So we can factor. How do you factor the numerator? Alright, you put 2 pair of parentheses. Factors of x squared is x and x. Right? Good. How do you factor so that you have minus 7x in the middle?
X minus 5, X minus 2.
Yes. X minus 5, x minus 2. Everybody okay with this factoring? Okay, denominator. Ooh, do you see this is x cubed? Let me remind you all those factoring formula. Okay, so you have, like, if you see a squared plus b squared, this cannot be factored. Just leave it like that. But if you see a squared minus b squared, that's a plus b times a minus b. Okay, everybody? And complete square, a plus b squared is a squared, and then what? Plus 2ab plus b squared. Right, everybody? And if it's a minus b squared, it's a squared minus 2ab plus b squared. Okay, now the new one. A cubed plus b cubed. If it's degree 3, what do? You have a factor of degree 1 terms. So a plus b, and then another factor of all the degree 2 terms. So they are a squared. But, so if this is plus, the linear factor, it will be plus. But the degree 2, the quadratic factor, it will be opposite sign of this. So if this is plus, then the middle term here will be minus ab plus b squared. Is that okay, everybody? Have you learned this before? Okay, I'm kind of remind you. If this is negative, a cubed minus b cubed, then this will be also negative. And the second factor, change the sign in the middle, it becomes plus. Is that okay, everybody? This is always plus. Yes, always plus. It's just the middle term. The sign is opposite of this. Yeah. Actually, this is very similar to this, but it does not have the 2 here. Okay. So in this case, 8 is what cube? 8 is like 2 cubed, right, everybody? So 2 cubed minus x cubed. We use the minus formula. With a is like the 2, the b is like the x. Do you agree, everybody? So we plug in. A is 2. B is x. Therefore, the first factor you get what? 2 minus x. Yes? So 2 minus x times 4 minus or plus? Plus 2x plus x squared. Right, everybody? Oh, do you see the bad guy? X minus 2 is the bad guy. It makes the numerator and denominator 0. But do you see this is x minus 2? This is 2 minus x. They're not exactly the same, right? Do you know that if you want to switch them, you will get a minus sign in front of it? Do you all know that? A y. Actually, y. So, okay, 2 minus x. You can think of this way. The 2 is like negative 2. Yes, everybody, 2 negative, make it positive. And then when you factor out the negative, it becomes minus 2, and then the second term becomes positive x. Therefore, you can, because it's addition, you can switch the order of the terms, so you get x minus 2. So that's why if you have subtraction and you switch them, you get a minus sign in front of it. Okay, everybody? So switch those and you get a minus sign in front of it. Alright, x minus 5, x minus 2. Switch it and you get a minus sign in front of it. In every step, please put the limits. Okay, as long as you still have x, then you have to carry the limits in that step. Good. Now, the bad guy is exactly x minus 2. We can cancel it. Therefore, we have x minus 5. Denominator is negative 4 plus 2x plus x squared. Right, everybody? Okay, now we can plug in again. So when we plug in number, whenever we see x, we place x by 2. Right, everybody? So in our expression, we don't have any x anymore. Then you don't need to put the limits. Okay, because the x is gone. So we plug in x is 2. So 2 minus 5, negative 4 plus 2 times 2 plus 2 squared. What's 2 minus 5? Negative 3. Denominator. 2 plus 2 times 2. 2 squared. 4 plus 4 plus 4. 12. Right? 12. Oh. Do you see? What can we cancel? Negative sign cancel. And the 3 cancel, we get 1, 4. Yay. So this is the answer. Okay? So I would say 3 steps. Step 1, you plug in the number and you get 0 over 0. Then you factor the numerator and denominator, cancel the bad guy. And after you cancel the bad guy, you can then plug in the number again. Okay, everybody? Do you still remember the steps? Okay, I think is this the first page? Like this page? Yes. These are the steps. Do you still have the step with you? Okay, good. All right. Let's keep going. Okay, so we did that one. Now let's do this one. Okay. Here, let's plug in step 1, plug in 0. H is 0. Oh, when we plug in H is 0, we get 1 over 2 plus 0 minus 1/2 over 0. For sure, is 0 over 0. Right, everybody? Okay, look at this. The numerator is not a polynomial. It's actually a difference of two fractions, right? In this case, you want to combine into a single fraction. All right, everybody? So combine into a single fraction. So maybe go back to your first page. Look at the steps. Do you still have some space here? So it depends on the problem. If you have fractions, you want to combine into a single fraction. And you want to simplify. Do you still have this in your first page? Yeah, so see, we have 3 types of problems. Binomial, you factor it, difference of square root, you multiply by conjugate. Now, if you see fractions in the numerator or denominator, you combine them into a single fraction and simplify. Okay, everybody? So this is the steps. All right, let's come back. Where are we? Here. Yes, here. Okay, so let's see. Limit h equal to 0. Long line, h is downstairs. Look at those two fractions. Common denominator will be 2 plus h and the 2. Do you agree, everybody? The two fractions, this fraction, the denominator is 2 plus h. This fraction, the denominator is 2. Then the common denominator is the product. Right, everybody? And look at the left. The left fraction, in order to get this common denominator, you multiply the top and bottom by 2. So multiply the top and bottom by 2, right? The second fraction, you have 2 in the denominator. So you multiply the top and bottom by 2 plus h. Yes, everybody? So minus 1 times 2 plus h. This is how we add fractions. Find the common denominator, right? And multiply appropriate factor to get the common denominator. Then you add the numerators. Yes, everybody? Okay, let's keep going. Limit h goes to 0. Okay. Let's distribute. So 2 minus 1 times 2 is minus 2. Minus 1 times h is minus h. Right, everybody? Alright, this is limit h goes to 0. Do you see the 2 minus 2 cancel? Right? Here, I also want to remind you. If you see a over b over c over d is a over b times d over c. When you divide it by a number, it's the same as multiply by its reciprocal, right? So in this case, my a is like minus h, and my b is like this. And do you see the h is like my c, and my d is like 1, right? So therefore, the minus h is like the a is in the numerator. Right? Minus h, write it down upstairs. And this, my b, is downstairs. Right? So 2 plus h times 2 is downstairs. Where do I put the h? Upstairs or downstairs? Downstairs. Right? That's like the c. We put it downstairs. See? We combine into a single fraction and we simplify. Do you see the bad guy? What's that? The h. H goes to 0, make the numerator and denominator 0. So we can cancel the bad guy. Alright, after you cancel the bad guy, what's left on the numerator? Yeah, you mean negative 1? And then 2 plus h times 2. See, we cancel the bad guy. Questions?
Yeah, before you did that, why did you move the H downstairs?
Because do you see the H is like the C?
Oh, yeah.
So you move the C downstairs.
Okay.
Because you don't want to have fraction in a fraction. You want to simplify it, right? Yeah. So otherwise, it's hard to see. You can cancel the H. You simplify it. Now you can see you can cancel the H. Yes. After we cancel the bad guy, we can then plug in the numbers again, right? Plug in number is here. Okay, we plug in H is 0, right? So we get denominator 2 times 2. What's that? Yeah. So minus 1 over 4 is the answer. So far, so good. So you see the steps are similar. 3 steps. Plug in the number. Ooh, something weird. Then you do more things depending on the problem, right? If you see a rational function, factor the numerator and denominator. If you see difference of square roots, multiply by conjugate. If you see a complicated fractions, combine into a single one and simplify it to see the bad guy. After you cancel the bad guy, you can then plug in the number again and get a nice answer. Okay, everybody? Alright, now you do example 5. Yes, we have seen all types of examples. Now you do this one. The first step, plug in the number first.
Yeah, I plugged it into the calculator.
X goes to 4.
Oh.
Yes, this is the same. You can erase your hand? Yeah. Oh. Yeah, yeah, yeah. This one is good. Are you able to replace this? Is this a special eraser that you use the regular eraser? Are you able to erase it?
No, yeah, it has to be this one.
Oh.
But like, look, I have like all the papers. And they all do the same thing.
Oh, and you use different color pen and can you use this eraser? Oh.
It's just they're the same height. It just needs to be this kind of eraser.
Magic eraser. And it's also magic pen. If I use the regular pen, will I this eraser?
I don't think so.
Conjugate. This should be plus is the middle sign. This one is still the same. This one, yeah. Multiply times 100. Okay, yeah, after you multiply it, this and this, you can get a squared minus b squared, which is the area of the and this one. Yeah. This square minus this square. Okay. When you see 0 over 0, you multiply by its conjugate. So don't move the limit.
Okay.
Yes. Yeah. Multiply by its conjugate. Conjugate is almost the same thing, but change the sign from minus to plus. Okay. You can use squares. You cannot do that. Multiply by its conjugate. Here. Multiply by its conjugate. And you want to do that one. So you have this guy square minus this square.
Yeah, that's right. And that would be the other way.
Yes. Oh, don't multiply. I'll go to factor right after it. Don't do that. Don't multiply. Factor out. Yes. Okay, 5 minutes left. Let's check our work. Okay, you all get 0 over 0, right? I saw all of you get 0 over 0. So that means we need to do something else. So like second step. And do you realize the numerator, we have difference of square roots? In that case, you multiply by the conjugate. The conjugate is almost the same thing, but you change the middle sign from minus to plus. Okay, don't change the sign inside the square root. Okay, everybody? So now we got limit x goes to 4 and 3x squared minus 11x minus 4, and the denominator we still have this guy, 4x minus 7 plus 3. But the numerator, you see, a minus b times a plus b is a squared. So the square root of 4x minus 7 squared minus b squared. Is that okay, everybody? Yeah, that's the rule. Therefore, the square and square root cancel. That's why we have 4x minus 7 minus what's 3 squared? 9. Yes. Okay, do you see the denominator? We get a quadratic factor, right? So keep in mind, here our goal is to factor. Don't multiply out, factor it.
Why you got shouldn't it be like -3 by 3 and not 3 squared?
Yeah, -3 times 3 is -3 squared.
No, but what if it was
Oh, if it's 4, then it's 4 squared. So it's whatever the b squared. A minus b times a plus b is a squared minus b squared. It's whatever the b is. Yes. Okay, yeah, so our goal is to factor it so we can see the back guy. Don't multiply out, never multiply out. How can you factor this? Thank you, 3x and x, you put what? Plus 1 and minus 4, yes. This will give us minus 12x, this will give us x. So when we add them together, we get minus 11x. Yes. And that's factor, just copy it. Square root of 4x minus 7 plus 3. Okay, keep going. What's the numerator? This is 4x. What's minus 7 minus 9? Minus 16. Oh, can you factor further? Yes, factor out the 4. What's left? X minus 4. Right, everybody? Do you see the bad guy? Yeah, it's x minus 4. Good. See, this problem is like a combination with the two problems we learned before. The numerator, you multiply by the conjugate. The denominator, you need to factor out. But you see the bad guy, you cancel the bad guy, then you can plug in the number again. So we have 4, 3x plus 1, and the square root of 4x minus 7 plus 3. We can plug in 4 now. X is 4. 3 times x is 4 plus 1. Square root of 4 times 4 minus 7 plus 3. Three times 4 is 12. 12 plus 1, 13. Here, 4 times 4, 16 minus 7. Square root of 9. 3 plus 3, 6. Oh, can you simplify it? 4 and 6 cancel. What do you get? 2 and 3. So 2 over, what's 3 times 13? 39. Yes. So this is the answer. Okay, 2 over 39. Have a nice long weekend. See you on Wednesday. And please do your homework. And if you have questions, feel free to let me know. Bye.